So in this video, I'm going to explain to you what materials engineering is, why it matters, and I'm going to explain the basic concepts of structure and properties of materials. If the concepts are all you care about, then I will put a mark in the video so you can skip straight to that part. So, what is a materials engineer? A materials engineer will utilize the materials created or synthesized by material scientists based off structure property correlations to create a new product. This means that a material engineer will take steel created by these scientists and manipulate it into other things, maybe a steel beam or a frying pan. Anything that includes turning the steel into something else is a materials engineering job. They figure out what to do with the materials based off its properties. Now, why does this matter? Why do materials engineers have jobs? What purpose do they serve? Well, if you try to imagine a world without materials engineering or science, then you would basically rid the world of everything. In the Bronze Age, materials engineers would have made something like instruments. Excuse the bad drawing of what should be a French horn or a tool of some sort. In the Stone Age, oftentimes they mixed clay to build their houses. Without materials engineering, you lose this. Today's age, you lose much, much more. You lose our phones that we spend so much time on. You lose all of the grand buildings that we put together using complex materials. You lose the car that you use to drive to work and much of other stuff. So now that we have the basic concept of what materials engineering is and why it is important, let's get into some of the basics. The structure. What is structure? Well, structure can be classified based off size. For example, we have 5 different classifications. We have subatomic and atomic. With subatomic being the inside of the atoms. For example, if we have an atom's nucleus, it has so much mass, aka so many protons and neutrons, and it interacts with its electrons in specific and unique ways. On the atomic level, we have interactions between the atoms. For example, you might think of water. The atomic interactions here are the bonds between the 2 hydrogen atoms and the oxygen atoms. The next 2 structures are going to be nano and micro levels. So nano is going to be the interactions between aggregates or clusters of atoms. For example, if we view these atoms in a close packed plane, it will have a unique set of properties versus something that's not so packed and ordered. If we have something with something called vacancies, which I will talk about in a later video, the time this video goes up, that video will not be in existence, but whenever it is, I will link that video probably to this one. These vacancies change the material's properties. If you think of a sponge is not at all dense or well formed. It causes it to be able to soak up other materials like water. Um, it affects that material's properties. On the micro level, at this point, you're going to be able to see the properties or the changes in the material with a microscope. Makes it really easy. This is going to be interactions viewed with a microscope, such as something called fault lines in a material. If we view this as a zoomed in portion of, say, a metal or something, then you will likely see fault lines. They will be very rigid. And what's essentially happened is the individual crystals of the metal, once they were formed, started expanding independently. And whenever these metals met each other, they did not grow in the same pattern. So we have boundaries between the crystals. This affects the properties of the crystal. For example, in the case of, say, the carbonization of a metal, carbon will much easily be able to travel along these fault lines due to the space between the much larger metal atoms, and it will be carburized faster than something with a totally um, ordered structure. Like if we had a crystal, one crystal form here and expand all the way to make the material. The last level of structure is going to be macro. So macro structures, these are interactions that we can see with the naked eye. We don't need a microscope or anything to be able to see these. This can be something like a metal drawn into a wire in order to conduct electricity from one place to another. It will be able to do it much more efficiently than, say, a big cube of metal trying to get electricity from one place to another. Excuse for a cube. Now that we know what the levels of structure are, we can look at the properties of materials. The different structures will affect the properties. Spelled that right. You guys see that? Spelled that right. I thought I didn't. It will affect the properties of the material. The properties are sorted out into 6 descriptions. You have mechanical properties. These are properties based off physical stimuli. For example, if we have a rubber band and I decide to stretch it out, then in fact it will stretch out. The force applied outward will cause this elastic band to stretch out and change its length. Another factor can be the strength of a material. For example, if I tried to do this with a circular rock, then either the rock would not expand at all, or the rock would break rather than expanding like the rubber band. The next property is going to be the electrical property. This is a property that we can see based off electrical stimuli. For example, if I were to run a current through a tree, it most likely would not travel up the tree, but rather it would burn a hole in that spot. Versus if I have a thin copper wire and I decide to charge it, then those electrons will be conducted through the wire from one place to another place. Similarly, this can also be how much storage it can hold. For example, if I were to try and put a chunk of aluminum foil into my controller in order to keep it charged, it would not work as well as a engineered battery meant to hold a charge. The next property is going to be the thermal property. So this is stimuli we see based off temperature. The kind of stuff we're looking for is expansion or heat capacity. For example, if we try to heat up a styrofoam block, it's going to take a lot more energy to change the temperature of this styrofoam block than it will a piece of metal. Pretend that this really looks like styrofoam and pretend this is like really shiny or something like that, like a piece of metal. If you place your hand on this piece of metal, you're going to feel it start going from cold to hot. Versus holding this styrofoam, it likely feels the same temperature the whole time. Expansion, you can think of a popcorn kernel. You put it in a microwave, and I believe it's the cornstarch within the popcorn will expand until it explodes. So this is the explosion happening. And then you have a delicious piece of popcorn. The next property is going to be magnetic. This one's pretty easy to understand. It's based off stimulus from other magnets. The way that we can see this property is how easily a material can become a magnet when it's exposed to a magnet. For example, if I put a magnet up to a tree, it will not be a magnet. Versus if I connect a piece of iron to this magnet, say an iron block, and then I put this iron block next to a staple, that staple will move towards the iron because it is becoming a magnet due to the influence of this magnet. That's an N, not an M. The other property is essentially how magnetic something already is. For example, if we sort this piece of material into a grid, and here we have the magnetic dipole moments, or whatever they're called, it's not going to be very magnetic because it's going all over the place. Versus the material with very sorted out directions, it's very much so going to pull anything magnetic in. Versus this one, which will not. The next property is the optical property, based off of electric I wonder how this affects the recording. We're gonna see. Electromagnetic or light radiation. The type of stuff that we're looking for is reflection or refraction. Basically, if we have a material here and we send light towards it, this is an L, it's a cursive L, and I can prove that to you because I can write out loser using this. See? Just like you and I. This is light though, not a loser. If we radiate light from this source into the material, does it refract it, or does it reflect it, or does it absorb it? That's an optical property. So the last property is going to be the longest one. I mean in length of the word, not in the amount of properties. It's the deteriorative property. This is based off chemical reactivity. For example, if we think of, again, iron, and you put it in some water, then you will get rust or oxidized iron. I think it's like FeO2 or something like that. Another example can be the Statue of Liberty. What was originally a brownish color was oxidized and turned what looks to be like a greenish kind of color. That is corrosion. That is the material corroding, is susceptible to corrosion. That is a deteriorative property of the material. And that's basically the end of this video. I'm going to quickly summarize everything real quick about materials engineers and what they do. They take the materials from the scientists. Scientists create this material, and the engineers worry about the processing of this material, what processing it goes through, which affects the structure on different levels of the material. Remember, you have the subatomic, atomic, nano, micro, and macro levels of structure, which affects the properties. Remember those 6 properties of the material. You have the mechanical, electrical, thermal, magnetic, optical, and deteriorative properties, which affects the performance or the use of the material. I hope I was able to teach you something that you didn't already know in this video. If I did, I really appreciate a like or a subscribe. I'm going to continue uploading videos. This is based off my materials course that I'm learning actually right now. This channel is actually more of a tool for me rather than for you guys. It's for me to study and to get a chance to practice explaining things so that I can hopefully be a better teacher in the future. Anyways, thank you for watching. I hope that you watch the rest of my videos as well. And yeah, that's it. Have a good day.